So here's what it says: 1 kg of ethylene glycol, whatever this is, antifreeze was added to a car radiator, which contains 4,450 grams of water. What are the boiling? So here we're looking at the question. What is the question saying? That is where we are looking. That is where you keep your eyes. Your eyes should remain fixed on the question. What are the boiling and freezing points of the solution? Right? So they are asking for temperature, freezing, solution, and then temperature, boiling of the solution. Right. You agree with me? These are the two questions that they've asked: the boiling, the freezing point, and the boiling of the solution. Now, they have then given you what KB and whatever. So we know they've told us that KB is equal to 0.5112 degrees Celsius per meter. Remember, if they say respectively, that means the same order they've given you the names is the order to take. So here we have KB, then KF. So that means this is KB, then this is KF, right? So we can have our KF like this. So we can say this is equal to 1.86 degrees Celsius per meter. Now, let's go ahead. We have been told to find TF and TB. So here's the thing. What are the formulas? What is the important formula to do with these things? Remember that we have this one most famous formula. And what did our famous formula say? It says that delta T is equal to Km, right? So if we are dealing with, let me reduce the size of the pen. So delta T is equal to Km. So if it's delta TB, it is KB times M. This is the first formula. Then the second one says that delta TB is equal to T boiling. What is higher at boiling? What is higher at boiling? Is the solution higher or is the solvent higher? We know that the solution is higher. So it will be solution minus the solvent, because we know that boiling gets elevated, right? It's boiling point elevation. So the temperature increases at boiling. We always want the bigger one to be the one that you write first. So we know that the solution, when you add salt, you increase the boiling point. So the solution has a higher boiling point than the solvent alone. So with these two formulas, these are the ones we are going to use to answer the question, because we are going to get delta T, then we'll put delta T, and we'll put T of solvent, the temperature of the solvent, then we'll get for solution. So let's go ahead and let's solve, right? I've just shown it for you, but I'm sorry. Now, this is us writing. First thing you write is that delta TB is equal to KBM, right? You can now say delta T boiling is equal to, what is it going to be here? The K for boiling is 0.512 degrees Celsius per meter, multiplying the molality. Remember that we have here the molality. Now, molality is the most beautiful thing, because there's something which I didn't do for you, and I'm sorry. Here's what you should do. What you should always do is, if you look at our data here, what are we doing? We have been told that 1 kg of ethylene glycol antifreeze was added to a car radiator which had this of water. So water is your solvent. Don't ever forget, we'll be dealing with water. Now, this guy is our solute, right? So what we want to do is, for us to be able to get the molality. Molality is a concentration, right? And we know how to get it. First thing we should get, because molality small m is going to be the number of moles of the solute over the kgs of the solvent, right? So we should be able to get this number of moles of solute over kgs of solvent. We have the kgs of solvent, 4,450 grams of water. We can convert it to kgs. So what we are going to do is we need to find the molality. So first, before we can put this formula into play, right? So I'm going to remove it for now. First thing is to convert, make sure as you do these calculations that your solute is in moles already. Right now I have 1 kg of that over. So now what I'm going to do is, here's the most famous formula. It says that number of moles is equal to mass over AR or MR. So in this case, it will be mass over MR, which is going to be, this is an important formula. Please, everybody know this. If you know these formulas, then we can work. Number of moles is mass over MR. So therefore, what I'm going to get is going to be, what is my mass? 1 kg. So it'll be 1.00 kg. But I must convert it to grams because MR will be in grams. So I'll multiply by, I want to remove kg, so I'll put 1 kg at the bottom. And then at the top, I'll put what I want is grams. And how many grams make 1 kg? 1,000 grams. So here at the end, this is how I convert. This is my mass. It's going to be in grams now, divided by MR. MR of this ethylene glycol, we have C2H6O2. So what I'm going to do is just put the things values for you. Carbon is a mass of 12, and since there are 2 of them here, we can see it's C2, so we'll multiply by 2. So it is 2 by 12 plus, we have 6 hydrogens, which is 6 by 1, okay, because hydrogen is a mass of 1, plus we have 2 oxygens, which have a mass of 16, so it will be 2 by 16. Then I can be able to get the number of moles. It's mass over MR. And this is grams. The MR is always in grams. So now we'll have 1,000 grams over 24 plus 6 plus 32. And you have 1,000 grams over 52. Is it? Or 62? So now we're going to say over 62 grams. We'll now say 1,000 divided by 62. We'll get 16.13 moles. Right? So here we have our value. We have the number of moles, and then we can now say that we can start to get our values. Delta TB is equal to KB times molality. We can find molality first if you want. Molality is equal to number of moles. So you can just say N of the solute divided by mass of the solvent. Okay, so it's going to be number of moles over 1 per kg. So what is the number of moles of solute? 16.13 moles divided by mass of the solvent. We saw it is 4,450 grams. So it will be 4,450 grams. Then we'll say 4,450 grams. We'll multiply by, we want to remove grams, so we'll say grams are going, and we want to convert it to kgs. So this would be 1,000 grams and 1 kg at the top. Then we have it like this. So here it is. So what we would now say is 0.13 divided by 4.4 divided 4.45. I'm sorry for that. All right, and when we do this calculation, we should get our 16.13 moles over 4.45 kgs. And we'll get 3.62 molar. Now we can say that our delta TB is equal to KB times M, which is going to be equal to, our KB is 0.512 degrees Celsius per molar, 0.512 degrees Celsius per molar, times 3.62 molar. So this is it. I say times 0.512, which is going to be, our boiling point elevation would be 1.856. 1.856, and this becomes degrees Celsius. Then we have found our delta T, and the last step would be to say that delta TB is equal to TB for the solution minus TB for the solvent. They want for the solution. So we take solvent to the other side. We say delta TB plus the temperature of solvent is equal to the temperature of solution. Now, what we put is 1.856 degrees Celsius plus the temperature of the solvent, the boiling one. Remember that this is B for boiling. Boiling temperature, what is our solvent? Water. What is the boiling? It's 100 degrees Celsius. We'll end up having the temperature B solution. So we can now say our boiling temperature would be 101.86 degrees Celsius. And this is our solution. All right. So this is our solution for the first one. Okay. It is 0.85 blah, blah, but this is our solution for the first one. Now we'll go to the next one in the next video. Bye for now.